Hello guys, welcome back to my YouTube channel. My name is Dharyll from Bat State University. So for today's video, we're going to tackle about the subnetting in IP networks in Chapter 8 on NetAcad. So without further ado, let's get started. So designing and implementing and managing an effective IP addressing plan ensures that the network can operate effectively and efficiently. This is especially true as the network of host connection to a network increases. So, understanding the hierarchical structure of the IP address and how to modify the hierarchy, so in order to more efficiently meet the routing requirement, is an important part when planning the IP addressing scheme. So basically, this chapter 8 in subnetting IP networks is talks about detail and creation and assignment of IP network and subnetwork addresses through the use of the subnet mask. So the first thing that we're going to tackle is the subnetting. Subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces is called subnetting. So what does subnetting do is subnetting reduce overall network traffic and it improves the network performance. And also, it enables an administrator to implement security policies such as which subnets are allowed or not allowed to communicate together. The main purpose of the subnetting is to help relieve the network congestion. So network congestion, when that happens, so you may have trouble in slow connection, or there might be a problem in transmitting the data inside or over a network. So the purpose of subnetting is to help to avoid or to relieve that in the network congestion. So the congestion is used to be a bigger problem than it is today, because it was more common for networks to use hubs than switches. So when that happens, when nodes on a network are are connected through a hub, the entire network acts as a single collision domain. So that is all about the subnetting. So next is the IPv4 subnets. So I've already talked about the IPv4 in my previous videos. So the IPv4 allows for a variations of the network and host segment of an IP address. So known as subnetting. So it can be used to physically and logically design a network. So also subnetting subnetwork addresses enhance to enhance the local routing capabilities. So when enhancing in the capabilities, it also do the reducing of the number of network addresses required. The IPv4 subnets are created by using one or more of the host bits as network bits. So two very important factors that will lead to the determination of the IP address block with the subnet mask are are the subnet required and the maximum number of hosts needed per subnet. There is an inverse relationship between the number of subnets and the number of the hosts. So the more bits that are borrowed to create a subnets, the fewer host bits are available. So therefore, when there are fewer hosts per subnet, so that is happens when the bits are borrowed to create subnets are fewer host bits that are available. So there are fewer hosts per subnets will occur. So next thing that we're going to tackle is the formula 2n raised 2 raised to n. So this formula is used to calculate how many how many addresses will be given will be rather will be available on each subnet. However, the network address and the broadcast address within a range are not usable. So therefore, in order to calculate the usable number of addresses, the calculation should be 2n 2 raised to n minus 2 is the required. The and the not usable host will be the minus 2, and also subnetting a subnet or using a variable length subnet mask or the VLSM was made or designed to avoid wasting addresses. So that is the other function of the VLSM or the subnetting a subnet. So next is what we're going to discuss is the IPv6 subnetting. So the IPv6 I've already also talked about this in my previous video. So the IPv6 addresses uses 128 bits to represent an address, which includes bits to be used for subnetting. So the second half of the address, which is least significant to 64 bits, is always used for the host only. So therefore, there is no comprise if we subnet the network. So, the 16 bits of subnet is equivalent to the of to that IPv4's class B network. The IPv6 subnetting, so it should be requires a different approach rather than the IPv4 subnetting. So while an IPv4 subnetting is about managing address scarcity, so IPv6 subnetting is about the building and addressing the hierarchy based on the number of routers and the network they support. So next is in other information, I'm going to discuss to you and tell to you some important key information and key terms here in chapter 8. So there are three primary considerations for planning address allocation. So which are the preventing the duplication of addresses. Second is providing and controlling access, and the monitoring and security and performance of the host. So first, I'm going to discuss to you the preventing the duplication of addresses. So it refers to the fact that each host is an internet network. Internet network must have a unique address. So without the proper planning and documentation, an address could be assigned to more than one host. So that will result in the access issue for both hosts, since there's also a unique addresses for each every host or devices. So next is in providing and controlling access. access. So that's in providing and controlling access. So to the fact that some hosts, such as servers, provide resources to internal hosts as well as to external hosts. So that is all about the providing and controlling access. So it refers more on some hosts such as servers that provide resources to internal hosts as well as to external hosts. So, but that's what you mean in that's what you mean in providing and controlling access. So, next is in the monitoring security and performance of the host. So here it means that network network traffic is examined for source IP addresses that are generating or receiving excessive packets. So in monitoring security and performance, also it is making sure that in every traffic is examined for the source IP addresses. So that are ones that generating or receiving the too many or excessive packets. Last thing that I want to discuss is careful planning is required. So why is it is required in careful planning? Because to make best use of the available address space. So size, location, um, use, and access requirements are all considerations in the address planning process. So after it is implemented, an IP network, of course, need to be tested to verify its connectivity and operational performance. So basically, that is all about in here in the chapter 8. So if you like this video, and if this video helped you in gaining more knowledge and learnings to your CCNA study, please support my channel and leave a like and share. So thank you for watching. Bye bye.